GarboCarbo, cheap and effective carbon capture for coal-fired power stations. Now, what is the problem? The problem is coal-fired power plants emit 46% of the 40 billion tons of carbon dioxide that get emitted into the atmosphere every single year. And these emissions are driving climate change and the upending of our lives as we know it. These same exact plants, however, are also providing an incredible baseload to our electrical grid. And the truth is, unless we're willing to make an incredible electrical and energy sacrifice to our consumption, these plants are really here to stay. On the plant side, coal-fired power plants, especially those based in the US, are missing out on up to $38.4 billion worth of federal carbon tax credits and subsidies every single year due to the lack of a sustainable and scalable carbon capture solution. Now, what is the solution? Well, carbon capture represents the best of both worlds, where we can practically eliminate carbon dioxide emissions without having to make any sacrifice to our energy consumption or energy usage. And at GarboCarbo, we're developing a highly scalable, easily integratable carbon scrubber capable of capturing over 98% of the carbon dioxide from flue gas released by these coal-fired power plants. Our technology along the process also generates limestone as a byproduct, which we intend to sell. Now, we've identified 3 unique market opportunities that are converging around the same rate. The first is that Congress has recently proposed to increase the federal carbon tax credit from $35 per ton of carbon dioxide captured and utilized to $60 per ton of carbon dioxide captured and utilized. The second is government regulation is actually forcing plants to reach net zero emissions, typically in the northern US and Canadian areas. This is typically by 2045, and this provides an incredibly strong incentive for these plants to adopt some kind of carbon capture technology such as ours. And finally, our byproduct is currently selling incredibly high at the moment and is only projected to increase within the next 5 years. These 3 market opportunities have created a market for both carbon capture as well as utilization. All right, so let's take a look at the market size. We performed a bottom-up market analysis, and we're looking at the byproduct, the capture, and the installation market opportunities to be a $128.3 billion opportunity for us. We hope to capture 2% of this market by 2027. We get this 2% because we're actually collaborating with a power plant based in the Midwest. They emit around 2% of the total US domestic carbon dioxide emissions every year. They've indicated strong interest in potentially working out a deal once we demonstrate the scalability of our technology to the coal-fired power plant level. And in fact, their CEO is one of our closest advisors. Now, I want to point out that our technology is not actually limited to just coal-fired power plants. Our technology can capture carbon dioxide from virtually any highly concentrated carbon dioxide emitter. That includes petroleum, natural gas plants, cement, and iron and steel mills. And when we combine all of these sources and include the US and Canadian markets, we're looking at a $280.8 billion total market opportunity by 2023. Now let's take a look at the competition and competitive landscape. The first thing I'd like to highlight is we run the lowest cost per ton of carbon dioxide captured / sequestered / utilized at $21.30. Our nearest competitor, Carbon Clean, is running around $27 per ton of carbon dioxide that they capture / sequester / utilize. However, it's important to note that they actually do not meet the industry gold standard of 95+% carbon dioxide capture rate, while we do. The next thing I'd like to highlight is we're the only ones amongst us and our competitors that are capable of generating a byproduct, let alone generating a revenue from that byproduct. And this is typically because our competitors, they're taking carbon dioxide from flue gas and they're injecting it into deep geological formations underground. So what they're doing is they're storing carbon dioxide underground. What we're doing is we're converting that carbon dioxide into something that's useful and something that we can sell instead. And finally, we're the only ones amongst us and our competitors that do host on-site capabilities. We're incredibly flexible with where we place our scrubbers, as we do not depend on predetermined geological underground formations. Our technology is totally above ground, it's entirely compact, and it's also incredibly scalable.
Now let's go over the GarboCarbo solution. Unfortunately, we can't reveal too much about the chemistry of our reactions because we're currently working with the Harvard Climate Circle to patent 2 of our primary processes. As you can see here, this is a black box diagram of our process. And as you can see, our proprietary minerals react with carbon dioxide in a series of water tanks and create high purity limestone, therefore capturing 98% of the carbon dioxide. This high purity limestone has high market value, and the input materials also are cheap and abundant. Therefore, they will actually, we will be able to scale our processes up to the power plant level. As you can see to the right, the flue gas treatment pipeline, we actually sit at the end of the pipeline. Therefore, we only have to focus on capturing just the carbon dioxide, and all extraneous gases, such as sulfur dioxide, are all captured previously.
Now let's consider exactly how we generate revenue with our product. We can split things up into two different revenue streams, the first of which being housed at the power plant, and the second of which being housed at the byproduct market. Now zooming into the power plant ecosystem, we're planning to charge a $150 million installation charge, and we're also planning on charging around 70% of the federal carbon capture tax credit, which right now amounts to about $25 per ton of CO2 that we capture. Now going to the byproduct market, we're looking to sell our limestone for around $429 per ton of CO2 that we capture. And we just want to really quickly point out that as our technology matures, we may end up switching to a business model revolving more around licensing. Now going into market adoption and market infiltration, our current strategy is to build long-term sustainable partnerships with power plants in the Midwest. Our main partner right now is Prairie State Energy Campus, one of the largest coal-fired power plants in the US. But we want to point out that we don't need a large number of customers in order to succeed financially. And this is just because of the nature of the market size as well as our business model. However, considering that GarboCarbo's main goal is to actually mitigate climate change in the long run, we do need a large number of customers. And in order to achieve this, we propose a plan that we dub plant-to-plant networking, where we essentially leverage existing partnerships with hopes of cultivating new partnerships. Now, our team is very diverse in nature, both in terms of our skill sets, as well as in terms of our roles within GarboCarbo. Kevin over here has extensive startup management experience, and he's our head of business, primarily looking at markets, so this involves market analysis and looking at our competitive landscape. Joshua over here has extensive lab experience, having been a researcher and is actually currently a researcher at Argonne National Labs, as well as the Illinois Sustainable Technology Center, and he's our head of technology. And I'm Pavan. I'm currently pursuing a secondary in energy and environment at Harvard, and I'm the head of business looking primarily into customer discovery. So this involves external affairs, as well as doing a lot of the customer interview process. Now, although we're a relatively young team, we want to point out that we've actually already dedicated over 5 years of our lives together trying to combat climate change through various projects that we've been working on. And where we lack experience because of our youth, we make up for it greatly with our extensive team of mentors and collaborators, a few of which we've listed here. Our primary technical advisor is Professor George Crabtree, who's a leading scientist at Argonne National Labs. He has validated every single one of the chemical processes that goes behind our reaction. Second, our main business advisor is Don Gaston, the CEO of Prairie State. He's shown strong interest in being our first customer once we can demonstrate the scalability of our product at the power plant level. Lastly, our technical advisor in the lab is Dr. Yongxi Liu, who has over 20 years of experience in the carbon capture market and has generously offered us space at Abbott Power Plant to demonstrate the viability of our large-scale prototype at the end of this calendar year. Now, in terms of where we are right now and where we're planning to go, the most tangible thing that we've accomplished is that we've already built a small-scale prototype that's capable of capturing around 908 tons of CO2 annually. And we'll be taking this prototype over the summer and scaling it up at Argonne National Labs. And during the fall and winter of this calendar year, we'll be deploying said prototype at Abbott Power Plant. Now, looking into customer discovery, we've already conducted over 30 interviews in the space, and we're planning to conduct more in the near future. And lastly, with regards to our intellectual property, we're working on patenting 2 of our processes. But that being said, we're more than just a product, and we're more than just a business. So once we get to the production stage and we're actually generating revenue, we pledge to donate some of our scrubbers to underdeveloped countries who can't right now transition to clean energy. And with that, we want to thank you all for your time, and we really appreciate your consideration.
Nice job, GarboCarbo. Judges, the floor is yours.
Okay, I'll go first. Great job. Mike, for initial question is, who's the brains behind the chemistry, and
I am. Yeah.
And how long did it take you to come up with a solution that works?
So I started in high school, where I worked with Professor George Crabtree. He provided me a lot of lab space at UIC, which is why we're sponsored by them. So basically, he's a professor at UIC as well as a director at Argonne. So he provided me with lab space. We worked on the reactions for like around 2 to 3 years, just like reading papers and then finally like creating the actual like prototype. Like after developing it. And then there's also peer-reviewed papers that also already have shown that the process actually works. So we kind of just cultivated that and created, like scaled it up a bit.
And who owns the IP that you've created?
Currently, no one owns the IP. We're trying to work with the Harvard Climate Circle to patent the processes.
It's impressive. I mean, you've got everyone at Exxon and no one is able to figure it out. And you guys did it. It's impressive.
Thank you.
Can you talk a little bit more about where you are in scaling? So you kind of talked about going into the plant later this year and scaling up, but how far have you made it in terms of actually having it operational and scaling and working?
Yeah, so we first created like our primary prototype that has just like, it for sure captures carbon dioxide, but we're working at Illinois Sustainable Technology Center right now. I'm working there to focus on like scaling it up, like 2 other processes that allows us to recycle materials. And then at Argonne National Labs, I'm working in the electrochemical discovery lab, where I'm working with some scientists to help me, scale it up even more when it comes to recycling and purifying materials.
In terms of our milestones, I can kind of talk a little bit about that. As Pavan mentioned, we are working on, over the summer and at the end of the year, we are working on developing or scaling up our current prototype to be able to capture carbon dioxide from a pilot, like a small 40 kilowatt pilot plant. Obviously, none of these plants are deployed, too small. After that, by December of 2024, I believe, our next milestone is to scale up to the 1 megawatt power plant levels. This is all being done at
Quick correction, 2023, December 2023.
Gotcha, okay. Yeah, 2023. And then our final milestone, which is the industry gold standard for carbon scrubbers at the moment, is the 10 megawatt plant. And that would be, we're aiming for February 2025 to finish that plant. After that, we have a couple different avenues. Like Pavan mentioned, we have a couple different business models that we're looking into. We can either go into licensing our technology or perhaps perform the project management or subcontracting ourselves.
It's a huge problem, and I applaud how much progress you guys have made to get after this, and we're all rooting for your success. How much capital do you need to raise to get this thing launched? Yeah,
so basically for our 40 kilowatt plant, we need around $40,000, and it's as shown in the diagram over there. Around 75% of it would be for equipment costs, and then around 15% would be for materials, and then around the rest would be for transportation, legal fees. And then for the 1 megawatt plant, we would need around $600,000, and it would be around 60% for equipment costs. This is because equipment actually scales logarithmically as we scale up, and our material costs scale linearly, so that's why we have a higher percentage for material cost. And the rest would be, again, for legal fees, wages, when we start hiring new people. And then for the 10 megawatt plant, it would be around maybe 50% for equipment, and then maybe around 20 to 30% would be materials, and then the rest would be legal fees and wages.
And I think you said this in your prepared comments, but one installation cost how much?
$150 million.
$150 million, and that hundreds of thousands of dollars is sufficient to get you 150 million unit?
So the numbers we mentioned here are up to the 10 megawatt scale. The actual deployed version is a 1600 megawatt scale. So when we're actually deploying, the 150 million is a break-even price that we've projected from our costs with our small scale prototype. So yeah, that 150 million is very long-term with respect to the projections we have here.
Thank you.
So can I follow up on your pricing model and that 150 million? So as a producer, I'm going to be charged 150 million for the installation, and then if I saw you right, you're going to capture about 70% of the available tax credits. So what is the inducement for me as the plant owner to install this product? What's my break-even point?
Yeah, so currently federal regulations or government regulations, especially Illinois by 2045, they're forcing plants to reach net zero at the risk of actually shutting down. So there's a pretty strong incentive to adopt some kind of carbon capture technology. Sorry, can you repeat the second half of your question?
But if I'm having to give you all 70% of my available tax credit, what is the inducement of utilizing your product, even though I'm being forced by government regulations to get to net zero? That's a pretty significant cut into what the tax credit would mean to me as the company owner, as the plant owner.
Gotcha. I think,
Go ahead.
yeah, so we know that these plants are being forced to adopt some kind of technology. And for us, it's not so much about making a nice deal to them, it's more about making a nice deal compared to our competitors. So I guess to kind of put some perspective, the Prairie State emits from between 15 and 20 million tons of carbon dioxide every year. At $10 per ton, that's easily $150 to $200 million that we're essentially giving to them once we install this carbon scrubber in their plant. To give some context in terms of our competitors' pricing at things like Baker Hughes or Sostera, their plants and their drilling for these geologic formations, so it's a little bit more expensive, but their direct facility is a $2 billion investment. And there's maintenance costs and things like that. So for us, it's more about not so much beating out or making a tasty deal. 70% is the majority of the tax credit, and et cetera. It's more about beating out our competitors because we know these plants have to adopt some kind of carbon capture technology.
And one really quick addendum to that. So right now they actually make $0 because they don't have a sustainable carbon capture solution in the power plant right now. So we've already spoken with Prairie State. They're our main collaborators right now, and they support the idea of taking this much out of their out of the carbon capture tax credit. So our primary customer is okay with the business model.
Okay. Thanks.
So can you elaborate a little bit more on this partnership with Prairie State? I mean, what's their commitment to supporting you guys?
Sure. So essentially, just to give a little bit of context, we linked up with Don Gaston, their CEO, and we had a tour in the power plant. We looked at the coal mines. We saw all the processes. We saw where our process would fit into their processes. So that was kind of how it started. And then later on, Don told us that basically, we revealed our technology to him, and he supported the idea. He ran it by his chemical engineers. All the chemical engineers supported our idea. And he essentially told us that he would be our first customers once we were able to demonstrate at the 10 megawatt scale that our solution works. And right now, we are 3 steps away from that. The first step would be the 40 kilowatt, and then the 1 megawatt, and then the 10 megawatt. But once we have that 10 megawatt solution working, he will be our first customer.
To kind of add on to that, we do not have any written contract in terms of partnership at the moment. Again, that will probably come once we are able to demonstrate the scalability of this technology. We are, deep tech, early stage. However, we do have I believe it's NDA, right? We do have an NDA, so we are collaborating, trying to understand their needs and what they're looking for in terms of a carbon capture solution.
Quick question about your byproduct sales. So I see you're selling the limestone. I get that component. Can you talk a little bit more about the CO2 you're capturing, and would you have the ability to sell the CO2 directly? Compressed CO2 is, there is a need for that, and wondering what the purity of that would be to be able to sell, or had you considered that?
So I can answer this question. First of all, that's a good question. So we're actually taking the carbon dioxide and we're converting it into limestone. So we're not actually capturing carbon dioxide and storing it in canisters. We are converting it into limestone. We were looking into perhaps trying to adjust the technology and maybe capture carbon dioxide and sell highly pure carbon dioxide. However, we believe that the limestone market is incredibly large, and a lot of our competitors, especially not our direct competitors, but a lot of these direct air capture plants, they have a really hard time of utilizing their carbon dioxide. So we're thinking perhaps that market has too many carbon dioxide, carbon capture players, and perhaps we should move into something that's a little less known, such as the industrial feedstock.
Thanks.
Great. Thank you very much to the University of Illinois Chicago.
Thank you.
GarboCarbo.
Thanks.